Hello, everybody. Welcome to this online tech talk. I hope you're doing well. My name is Blaise Pele, and I'm a product manager on the AWS AppSync team. For our sessions today, I would like to talk to you about AppSync GraphQL APIs and how AppSync is helping teams come together to build APIs that scale without losing velocity using our new federated API feature, Merged API. On our agenda today, I'll briefly cover what GraphQL is and how GraphQL solves many of the issues we run into when building APIs. I'll talk about AppSync and how it helps you meet your business goals with GraphQL endpoint. And finally, I'll cover our merged API feature. GraphQL is a query language for APIs. It is a specification that allows you to build efficient APIs. But to understand why GraphQL is so powerful and why so many enterprises are adopting it as a solution, it's important to understand the challenges that come with building APIs. Many API solutions today are built using REST-like or RESTful interfaces. These types of APIs typically work well when there's a single or a couple of data sources involved. However, as APIs grow and data spreads across many data sources and many microservices, things become more complicated. Take, for example, a shopping application that runs across multiple platforms and retrieves information from multiple data sources. You can see it here on screen. I have my web application, my iOS application, my Android application, and they are interacting with multiple data sources fronted by different APIs. So I have my product, my orders, and my carts. And in this application, if I want to access my cart to see my products, first I've got to access my cart, find out the ID of my cart, for example. Then I access my orders, find out the ID of my orders, and then based on that, I access my product. There's a lot of things going on there. Each data source is different, and each client has to deal with the inconsistencies when they fetch data. The way they retrieve a cart, for example, may be different from how they retrieve a product. They have to know the format and modify the data when they receive it. This means that developers have to introduce a certain level of additional complexity just to interact with the data that they're fetching. With all of these dependencies between the different resources that exist between the cart, the order, and the product, clients also have to fetch data in sequence, which adds latency and inefficiencies. As I said, if I want to get information about my orders, I first have to get information about my cart, then my orders, and then my product. So there is a lot of back and forth that could be going on here, which adds latency and inefficiencies because every single time I have to fetch a lot of data, not knowing how that data is probably going to impact other data downstream that I have to fetch. So this makes it harder for clients to deal with data. Also keep in mind that each client, although they are running the same application, have different needs. A web application that's running on a on a web browser on a laptop or a computer has a lot more real estate and typically displays a lot more data. Compare that to an iOS or Android or mobile application that's running on a small platform with a smaller real estate. That application may not need to fetch as much information. But with REST and RESTful APIs, there's not always an easy way of specifying what each client wants to get. So this is not optimal, and it also adds a lot of complexity for the developers that have to think about the different use case for the different platforms that they're building their clients for. Definitely not optimal. With GraphQL, we can simplify these architectures. With GraphQL, you have a single endpoint that you can use to interact with all of your data sources. So as you can see on screen here, before we had multiple endpoints. Now we only have a single endpoint that all of our applications can use to interact with the data. The GraphQL endpoint provides a consistent format to interact with the data. And the GraphQL API resolves the queries into backend, abstracting all of the complexity away. All of our all of what our clients are seeing is just the API, and they have a standard interface that they can use to interact with the data. So the view for the client's perspective is simple and straightforward. There's only a single API, and that's the only thing we're talking with. Clients don't have to worry about where the data resides. Is it in a microservice? Is it in a relational database or a non-relational database? Also, with GraphQL, each client can request exactly the data that they want, and they just get that. So there's no more need to add this additional functionality to parse through data or to transform data or shape data into something else. Clients ask for one thing and they get exactly what they asked for. This allows clients to be more efficient and robust when it comes to handling data. So GraphQL can help you achieve that. Now that you kind of understand the benefits of GraphQL, you may be at a stage where you are ready to take the plunge and start using it to meet your own business goals. Now, if we think about it, you could go about this in a couple of different ways. You could go out and launch your own self hosted GraphQL solution and deal with all of the heavy lifting that comes along with it. But this requires a lot of work. And if you think about it, it takes time away from what you are working towards that is critical for your customers. Developers want to work on the things that matter the most for their customers. And having to work on backend infrastructure that doesn't really meet those business goals doesn't help them do that. AWS AppSync can help you achieve those business goals a lot quicker by offering this managed service. So AWS AppSync is a service that provides fully managed GraphQL APIs along with real-time and pub/sub capabilities. Now, this is important because, as I mentioned, self-management of GraphQL is complex, costly, and tedious. If you simply think about it, when you deploy your own architecture, your own infrastructure, you have to manage that infrastructure. You have to set up servers. You have to dedicate resources to administer, configure, patch those servers. This is an additional work that you have to take on. Also, with your own self-hosted solution, there's more code that you actually have to take care of that you inherit. And when you deal with more code, you end up dealing with more complexities. You not only need to understand how that code works, you need to understand what every single change to that code means to your application. You need to instrument it, you need to operate it. Every single change is another real wrinkle in your operational system. So that is another thing that you have to think about. And then last but not least, of course, there's security. APIs provide the interface that exposes your data. So you want to make sure that you have the right security resources and security posture set up to protect your API. This is something that can be really hard to do. And so you want to definitely spend some time thinking about what that is. And as you spend a lot of time thinking about that, again, this takes your time away from working on the solutions, on the features that are most important for your developers, for your customers. With AWS AppSync, AppSync offers the simplest way of building scalable APIs that you can connect to your data. So, as opposed to a self managed solution, you can look at how AppSync works. And first of all, it's 100% serverless. So when we say serverless, there are no servers to manage. But not only that, AppSync scales with your need. So as you send more traffic towards your AppSync GraphQL endpoint, your GraphQL API, AppSync will scale to meet your demand. This is something that you don't have to think about or worry about. There's no additional provisioning that you need to do for high traffic events. And when you don't use the API, it scales down and you pay for what you use. There's less code and so less complexity that you have to take on, right? AppSync will take care of handling all of those really important but table stake type of features that you need to have in your GraphQL server to make that API available. But you don't need to have to manage that code. You can really focus on managing the code to implement the features that matters to your customers. And last but not least, AppSync is secure and performant. Security is our main priority at AWS. So when we built AppSync, we thought about all of the different things that we needed to do to make sure that your API was secure. And if you look at AppSync from an end-to-end perspective, from the ingest point when request comes in, you've got WAF that you can put in front of AppSync, or web application firewall, to protect your APIs. AppSync provides multiple authorization modes of authorizations that you can use to grant access to the API. So you can have different type of users or different type of clients connecting to your API using the mode of authorization that is best suited for them. Whether that be using OIDC or using Cognito user pool or using an API key or even using an IAM role to access the API. AppSync can do that. And then when it comes to interacting with your backend data sources, AppSync also has security mechanisms there, like IAM rules that grants AppSync specific permissions to interact with your resources. So from an end-to-end standpoint, AppSync has you covered. And AppSync provides the tools that you need to monitor your API and to track the usage of your APIs. All things that you need to have to in order to understand how your API works and to make sure that it's being used properly. Getting started with AppSync is fairly simple. First, you need to model and define your data in your GraphQL schema. Now, the schema defines the data that is available in your API and automatically generates the documentation for your API users. The schema is a powerful thing. It is the source of truth for your API. It is a simple document that you and your API consumers can easily understand. So, as you model your API and define the things that are available to your API, your own API consumers can actually access that schema to understand how the API works. So, not only are you building your API, you are documenting your API and documenting the functionality that is available. So, it's useful for developers and for the consumers of the application. Then in your API, you have resolvers. So ultimately, the goal of your API is to make certain amount of data available to your clients. And resolvers are the components that provide the logical glue between your schema and the data that's in your data sources. You're using resolvers, you can map an operation, a request that comes in your schema with a specific data source. We call them resolvers because they are built-in functions in GraphQL that resolve operations with the data in your data sources. So these are the three things that you need to keep in mind when you talk about when you want to get started with AppSync: your schemas, your resolvers, and your data sources. And then on the data source side, AppSync can work with a multiple of data sources, from DynamoDB tables to Amazon Aurora database instances, to Lambda function, to any HTTP endpoint that you can configure. AppSync has integration that allows you to work with multiple types of data, so you can make multiple types of data available through your API. Having said all this, AppSync is great for front-end developers and front-end teams. As a front-end developer, you don't have to spend time building a complicated backend solution, which means that you can spend more time building your front-end application and ship quicker. You can spend more time architecting the things that matter to your customers and ship those features. Your apps are more performant because they can ask for all of the data that they need from a single API. And using the schema, you can create relationships between the different data types that you have. So not only do you document what your API can do, like for example, specifying that you have orders and products, you can create relationship between those entities. And then your clients can say something like, I want to get all of the orders and all of the products associated with those orders in a single request. Making a single request and cutting down on the latency greatly improves your API, your client performance. And then when you want to implement additional use cases, advanced use cases, things like real time implementation. For example, let's say you wanted to implement some type of chat functionality where you want your client to receive notifications about new messages in real time. AppSync can help you do that because AppSync provides and supports that type of functionality. So AppSync can help you add functionality like real time to implement things like chat functionality, implementing things like live scoreboard for score updates, a whole bunch of functionality that would only work well if you've got that real time component implemented in your applications. And with AppSync, you can do that easily just by turning on a feature. This is great for your backend, and it's also great for your clients because a lot of time those type of functionalities are really hard to implement, and clients have to defer to using things like constant polling to get those updates in near but not quite real time. With AppSync, you can get those in real time without having to do a lot of that hard work. So great for front end developers and great for front end teams. AppSync is also built for backend teams. As I mentioned, building a complete and complex API that scale is not simple. It is fairly easy to do with AppSync because AppSync is serverless and scales with your demand. Additionally, with committed SLAs, you can rely on AppSync to meet your latency and performance needs. AppSync is also part of the AWS ecosystem, which means it plays nice within the AWS environment. So you can easily plug it into your existing AWS backend and leverage services like CloudWatch, IAM, and X-Ray to build your API and to implement the functionality that you need in your API. AppSync provides multiple security features to help you with auth and access control. I talked about WAF, I talked about the different authorization modes that it supports. This makes the job of backend teams really simple when it comes to adding that type of functionality. And finally, AppSync merge API feature allows teams to work independently to build federated and merged APIs. So let's talk a bit more about merged APIs. As usage of GraphQL grows in an organization, the need to federate API configuration across multiple teams and AWS accounts emerges. Teams within a single organization want to be able to create, manage, and deploy resources independently in order to separate concerns and increase their development velocity. To do this, they need to be able to work on their own API. Working on the same API without proper guardrails can lead to accidental breaking changes. To maintain their velocity, team needs the isolation and ownership that will allow them to stay nimble and move quickly. So you may have a situation where you have an organization again that manages different pieces of data, different APIs and different components. It's very important for those teams to be able to do the work that they need to do without running into um, uh, con- conflicts of data and mismatch of data. And this is something that can happen when a whole team is working on a single API. It requires a lot more collaboration and makes accidents lot more likely. So we need a solution that will enable all of these teams to work independently, but then come together to offer that API that meets the business goals and business objectives. With AppSync Merge APIs, teams can independently create and deploy their AppSync resources. So this includes things like your GraphQL schema, your resolvers, your data sources, and they can continue to do that while exposing the entire data graph to a single AppSync GraphQL endpoint. So with Merged API, every team retains control of their source APIs where they can take their time and move at their own pace to implement the features that they need to work on. And then they can bring all of that functionality together into a single Merged API. So Merge API enables cross-team collaboration while allowing all of these teams to operate independently. With merged APIs, organization can simply import the resources of multiple development team owned source AppSync APIs into a single merged AppSync API. And they can then expose that merged API to their clients. Take for example the situation that we have here. We have two teams, Team A and Team B, each working on their API. Team A owns the orders in their backend, and their orders are stored in Amazon DynamoDB. Team B owns the product information, and they store that information in their Amazon Aurora serverless database instance. Now, because there is this separation of concern and separation of ownership, each team can move at its own velocity and manage the pieces of the system that they are responsible for. Then, when they need to come together, they can use merged API to create this single GraphQL endpoint. A merged API is created by specifying the Amazon resource name, what you may know as ARN for short. So they specify the ARN of a list of source AppSync APIs. As part of the merge API creation and update process, AppSync performs a merge of all of the metadata associated with the source APIs, including, like I mentioned, the types, the data sources, and the resolvers. So all of that is merged into a single API. For simple use cases where no definition into source APIs conflict, there's no need to modify anything at your source API. You just bring those two APIs together and you've got your merged API. The resulting merge API respects all of the configuration that you did in your source APIs and exposes a single GraphQL endpoint that allows customers to access all of the data. So we start with this single API, and we start um, we start with a single with two APIs. I'm sorry, two APIs from Team A and Team B, and then we end up with a merged API that handles all of the resolution of queries and operations that is required. So as you can see here, I've got now my merged API that has a merged GraphQL schema built from the schemas of Team A and Team B. And in my merged API, I have got my resolvers that I configured from the Team A and Team B resolvers. When I need to execute a query, my merged API simply handles the resolution of that query and fetches the data from the data sources and Teams A and Teams B account. Merge API can work across accounts or in a single account. So not only does it allow you to have different GraphQL APIs, you can also have different GraphQL APIs in different accounts. Again, working with that separation of concern and making sure that each team can work in its own in their own environment. So if we look at how Merge API works versus some of the existing approaches that you may have seen when it comes to things like federation, it is clear that there are many solutions and patterns in the GraphQL community for combining schemas and enabling teams to collaborate through a shared graph. AppSync Merge API adopts a build time approach to schema composition, where source APIs are combined into a separate merged API. An alternative approach is to layer a runtime router across multiple source APIs or subgraphs. In that runtime approach, the router receives the request and references a combined schema that is maintained as metadata. So if we look at the runtime composition, there's a central gateway. This is where you have this runtime router. And for each request that comes in, the router is responsible for routing the request. This means that you're going to have additional network hops, which can add complexity and add to latency of resolving those requests. It also makes it really hard to support things like real-time subscriptions, where you need to be able to send notifications when a mutation is executed against your API. With the build-time composition approach that Merge API takes, there's a single API composed at build time and no other API involved in the execution path. What this means is that you've got a single server, and it greatly simplifies the operation and performance management. There's no multiple hops that we have to take. There's no runtime routing that has to happen. And it also allows us to support things like real-time subscriptions. This comes out of the box with merged API, with the merged API solution, something that AppSync GraphQL endpoints already support today and is available for merged APIs. So what I want to do now is jump into a demo. Talked a little bit about AppSync GraphQL APIs and talked about merged API. Let's jump to a demo and see how it actually works. So for the demo, I'm going to go over the merge API feature. Um, what I'm going to do is expand on one of the scenarios that I just went over. I'm going to go over a situation where we have two APIs. One API that is responsible for getting in information about users, and another API that is owned by another team that deals with the orders. So this is like an e-commerce application within an e-commerce system, and we are building an API that will allow customers to get some information about their account and get some information about their orders. So to do this, I'm going to do a couple of things. First, I'm going to create the two source APIs that are going to come together to form the merged API. So I am in the AWS AppSync console right now, and I'm going to create an API. Here I have the option of creating a standard GraphQL API and a merged API. I'm going to choose GraphQL API, and I'm going to choose design from scratch. I click next. I name my API. I'm going to call it user API, and I like to attach a date to my APIs. Contact details, this is optional, but this can be useful when you have multiple teams and you have building merged APIs. So I'm going to just set an email address, but this could be anything. Um, then I have the option of setting of using the private API feature. The private API feature would make this API only accessible from my VPCs. But here I am not going to do that. I'm going to leave this API as publicly available. And then I am going to use our modeling capability within this wizard to create a resource for my GraphQL schema. So I am going to create a model that is a type that is backed by a DynamoDB table. So what this does is essentially it allows me to create a model, and a model is simply a type with pre-configured queries, mutations, and subscriptions. So this is a great way to get started. It creates the type for you and creates all of the operations, and the wizard will also create the table for you, and then associate the specific roles that AWS AppSync needs to interact with the table that it's going to create. I'm going to call it user. I'm going to create a first field called ID. So this is going to be the main ID of my user, and I'm going to click that this is required. So a user always needs to have an ID. I'm going to give the user a name and give the user an address. So maybe this is the address that we ship orders to. Then I'm going to configure a table. Again, this is going to be my user table. I'm going to set a primary key up to ID. So this into DynamoDB table, this is how we're going to be fetching individual items. And I don't need to set an additional index. So I click next. I review my changes. So it's an API that I'm designing from scratch. You see the name, the features, the contact detail, and then the information about the model that we are setting up, and then the table. And now I can click on Create API. So the console creates my API, creates my DynamoDB tables for me. This is pretty quick, so I'm just going to wait a second for it to complete. And we can see that everything is being created. I have my schema, and I can try this out really quickly. I can go in my query editor, and I've got something already preset for me here. So I can specify a name, and let's say that the name is going to be Bliss. And I specify an address, and I'm just going to say Seattle, Washington. And I can run create user. And you can see that it created a user, and AppSync has a lot of functionalities and utilities that you can use. It automatically created a unique identifier for this user. And if I want to list the users, I can list a user here as well. Just for fun's sake, I can create another user named John, and maybe this user is in Tacoma, Washington. Um, and now create the user. And again, list users, I've got two users here. Okay, awesome. So I can go back to my API table, and I'm going to do the same thing again quickly, but this time for an order API. So I call it order API, match the date, and this is the order team at example.com. Again, I could make this private, but I'm not going to do that now. And you can definitely use private APIs with your merged APIs as well. So if you want your source APIs to be private and your merged API to be public, you can do that as well. I'm going to define my model, call it order, um, specify a field, ID is required, the order, I don't know, maybe there's details, it's a string, and we need to know who the order belongs to. So there's a user ID, and I say yes, the order is required. Um, and then maybe there's we set the product name, and then we set the quantity, right? So and then I can set this to an int. Um, and so the user ID and the ID is required, but everything else is optional. Um, order, again, I create my table, and I set my primary key to ID. And then what I'm going to do is I'm going to create an index that we are going to use later. And the index is something that is going to allow us to get information um, about our information, to get our orders that are related to users. So I'm just going to create this index, and I'm going to call it ID product index. So let me just save that because I'm going to use that later. And I don't need a sort key. So I'm just going to click none and configure my table. So next, create API. So it's going to do the same thing, create the APIs. And then we'll use that here in a sec. While this is going on, I'm just going to come to the screen, find my user API that I had. I can click on my user API, again, go in my queries, and then run list users. Let's say that I grab my user ID. I can now go in my function, in my order API, and I am going to do the same thing. I am going to create an order. So the ID is, here's my user ID, and the product is, I don't know, I'm getting some cookies, and then yeah, I'm getting 68 cookies because I want a lot of cookies. So I can create the order. Again, I can then say I want some sandals, and maybe I only need one pair of sandals, and create another order, and then I can list my orders. And I could do this. I could have anything in there, and maybe this is a random ID for I don't know. I need a chair or something like that, and maybe I'm buying a couple of them. Um, Create another order, and then I can list my orders. Okay. So now that I've done that, I can actually now merge my APIs. So to merge it, to create a merge API, it's fairly straightforward. I click on merged APIs. I click on next, and I'm going to call this my ecom API again. And this is main team or something like that owns this. Um, So for merge API, you need to specify a service role so that the merge API can actually securely access the imported source API resources. So it's important that you do this. Um, I am going to use a role that I already have, but you can have you can have the console create a brand new role for you that will allow you um, to actually get started quickly. But because I already have one, I am going to look it up here. I'm going to look it up here. Just click here. And here it is. So I'm going to use this. Again, I don't want this to be private. Then I can come on this screen and do add source APIs. And I'm just going to look for my APIs. So I've got order. So I'm going to select it. And I had my user. I'm going to select that. Like add source APIs. So you see that I've got two APIs set up here. Now, one thing that you'll notice is that you can actually import APIs from other AWS accounts, right? So if you have another account, your other accounts can share APIs with you via the AWS resource access manager, RAM for short. So it's very easy for an other account to share resources with you using RAM, which is the 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 standard way of doing this. And then when those resources have been added with you, you can simply add them by clicking add source APIs. And so here it's telling you select API from other AWS accounts that have been shared with you with the resource access manager, right? So you can find out how the resource access manager works. And then when they've been shared with you and you've been given permissions to access those APIs, you can bring them into your merged API. Going to click next. Primary authorization mode. At the very least, you need to have the same authorization mode as your incoming APIs, and they're using API key. So we're going to use API key. I'm going to click next. Review the details. I think everything looks good. So I'm going to do create API. And you can see that my API is being created. And now it's ready. So I can just click on this. You see here that I have details about my APIs. They are ready to go. I can see the contact information. So if I need to contact whoever owns this API, maybe there's a feature I want them to implement, I can get the contact information here. And then here's the association ID, just a reference to keep track of what's been going on. So if I go to queries now, you can see that I have my orders and I have my users, right, in a single API. I didn't really have to do anything. So let's see, can I get my users? Uh, List users. Yep, I got them here. Let's add the name as well. Yep, got them here. You can see that there's the information. And can I do the same thing for order? List orders, items, ID, user ID, products. We run to query. Yep, and you can see that I have all the information here, my cookies, the chair, the sandals. So just with a few clicks, we were able to merge the API. We didn't really have to do anything. But now let's think about a scenario. I've got my orders and I got my users, but there's no relationship between the two. What if, as a user, I wanted to be able to do a single query to get my user information along with my orders? How can we do that? Well, that's easy enough. I can simply send a request to the orders team to implement some functionality on their side that will allow me to see this data in my merged API. So I'm going to go to my orders API. I'm going to go to settings. One thing that I'm going to do here is, sorry, I'm going to go here. Oh, I'm going to go to settings actually. I'm going to refresh this page because it's been merged. And now I see information about my merged API. So from the source API, you can see the API that it's been merged into. But one of the things that I can do, anytime I make a change, I can do merge now, right? But I can also come in here and do automatically merge API changes so that anytime I change my APIs, they will automatically be pushed to the merged API. I click save and I save my settings. Now, I'm going to go to my schema, and what I'm going to do is, if you remember in the order, we had a user ID, right? Now, to make this available to my merged API based on a specific user ID, I can create a user type here. And I can create orders. Well, so I'm creating a type with a field called orders that returns a list of orders. So I save my schema. And now I can look up my user and I can attach a resolver to this user. So I'm going to write my resolver in JavaScript. It's going to be fairly straightforward. This is a pipeline resolver. So this is the main resolver. And I just click create here. This pipeline resolver can call a function. So I'm then going to create a function. And this function retrieves information from a data source. This is my data source. If you remember, I created it. It's called order with the timestamp. And this, I'm just going to call it get order for user. And I'm going to create it real quick. Then I'm going to make sure I attach it here. And I'm going to click save. Then I'm going to go back and edit my function. And all I really need to do in my function is add some code that will allow me to fetch orders based on a user ID. So here's what's going on here. I've got a piece of code that I'm going to explain briefly. I have a function, a request handler that is responsible for handling requests coming in. When the reset request comes in, the idea here is that this is a field for my user type. So when I want to resolve the orders field for my user type, I have access to the ID of my user, right? So I'm building this knowing that in the user API, when I try to resolve a user, it will return the ID of the user. So I can simply get my user ID here from my source, and then I can build a request, which is a query towards my DynamoDB table. So the operation is a query, and the query expression that I'm putting here is essentially saying, get me all of the orders where the user ID is equal to user ID. And so if you have the user ID here, and I'm saying get me all of the orders where the user ID is equal to user ID, based on the ID product index that we created. And that's it. I can log my request if I want to, and then I send my request, and then I return to items. I save my functions. And now I can go back to my merged API, which is here. First, one thing that I can do just to show you how um, auto merging works, if I look here, you see that it's been auto merged. Things have been auto merged already. So I can go into my ecom application. So now that we've created this additional resolver in our orders API, and we have merged everything into our merged API, I can come here again and I can list my users. So I can get my ID and name. So we see that there's Brice here with my ID and John with my ID. I can copy the ID for Brice and I can create a new query where I'm simply getting the user of this ID. I'm getting his name, ID, and address, and I'm getting this new field that has been merged into the merged API. So this is now a combination of two fields that allows me to get data from my user's API and get data from my orders API. So the way to think about it is that the merge API is getting the data from the user API data source and then getting some other data from the orders API data source. So I click run my query, and you can see here that not only do I have, let me make this a bit bigger, not only do I have my user, right? You see my name, ID, and address. I've got my orders. So I was able to combine data from two different resolvers in two different APIs into my merged API. So this is pretty amazing if you ask me. And just to confirm, I'm only seeing the cookies and the sandals that were associated with this user. I'm not seeing the chair that was associated with the user John. So that's pretty cool. Some other things that you can do, you have two different APIs, but sometimes there is some data that you may have in one API that you don't want to see in another API. So we have introduced some additional resources that directives in your schema that allows you to do this. For example, let's say that there's some metadata information into order that should only be visible from the order API, but should not be exposed to the merged API that is going out to our customers. In the order API, I can use the hidden directive to hide this field. So I put hidden on my metadata field and I save my schema. Now I've got auto merge on for this API, but I am going to go in settings and simply click merge, which is going to merge it now. Now, if I go back to my ecom API, I can refresh. And what you'll see is that in my orders, there's no metadata um, field, right? So this metadata field is hidden from the merged API. Additionally, you may have a situation where you have got a type or a field that clashes with another field in another API. And you still want to expose that field, but you just want to get rid of the clash. So I can create a type here called legacy thing. And I'm just, to be brief, I'm just going to call it string. So if I save this schema, and again, I think I have auto merge on. So let me just go to my ecom API. But this time I'm going to go to my schema. So in the schema, I can see um, I can see my merge schema as well. So I can just come right here and look at my merge schema. Let me see if I can see my type. What was it called? Legacy thing. So you can see legacy thing here. But this is not what I want to see. So I can use another um, directive called renamed to, and I simply want to call it thing. Save my schema. The save is complete. It's going to auto merge automatically. I can come here and refresh my schema again. Now, if we go further down, you can see that I see thing only. I don't see legacy thing. So this can help you deal with those situations. You can also have a situation where um, you have information that again clashes in different APIs, but you know where the source of truth is. You know in which API you know which API needs to control the source of truth. So, for example, um, I could introduce in my user. I am in my order API. Let's say that I introduce something, and I'm going to call it critical. This is my order API. I'm going to call it critical, and it's just a string. So I save the schema, then I look up my user, and I am going to attach a simple JavaScript function here, and I'm just going to say this is local from this is the order API. So I create this, I save it. Um, Now, if I go to my queries editor here, actually, let me just go in my ecom merged API because everything is merged automatically right now. I can go to queries, and if I do get user, let me remove this. I can click on critical and I click run, and you see local from order API. But this critical information, I don't want it to come from the order API. I know that this is something that should be coming from the user API. So in my user API, I can go in my schema. I can look up my user. I add the critical field, which I'm calling string, and I'm going to do the same thing. I save the schema. I look up the user type, and I look up the user field called critical, and I simply attach a JavaScript resolver here. And this time I call it, we are going to call it, let me see if I can get fancy with what I'm doing. Just going to do create. But then what I'm going to do is on that field, I'm going to add a directive called canonical. And canonical means that this is the canonical source of truth for this field. So this overrides anything else if there is a conflict from any other source APIs. So I'm going to click save. I don't have auto merge turned on for this API. I'm going to go to settings, and let me refresh this page. I'm simply going to do merge now. So merge schedule, merge success. And so let's try this again. So we were getting local from order API. Now if I run this, critical, right? So I'm getting it from the user API because even though those two fields are there, I have specifically said that this critical field is coming from my source, my user API. That is the canonical source of truth. So this summarizes all of the features that you have available for merged API. And I think this is the end of our demo. So that was the demo. Hopefully, it answers a lot of the questions that you may have had. I want to thank you for joining me in this webinar where we covered AWS AppSync and we discussed our new merged API feature. If you want to learn more about AppSync, please check out our AppSync product page. I invite you to check out AppSync into AWS Console to see how it works and to see how it can help you reach your business goals. Thank you again for joining. My name is Brice Pele. I'll see you next time.